A mechanical wave is a wave that is a vibration in matter, transferring energy through a material. Not all waves are like this. For example, electromagnetic waves, such as visible light, are not mechanical because they can travel through the vacuum of space to reach us from the sun. Mechanical waves include water waves, sound waves, earthquake waves, and many more. Like all waves, those of the mechanical variety have peaks or crests and troughs. They also have a frequency, which is the number of waves that pass by per second, and a wavelength, which is the distance from one peak to the next or one trough to the next. To create a mechanical wave, some initial energy has to be put into it. This is the energy that will then be transferred by the wave. How you provide this energy depends on the medium and type of wave. For example, you could drop a stone in some water and create a water wave. You could also speak loudly to create a sound wave, or you might shake a slinky up and down to create a wave in the slinky. But either way, the energy you expend to do the action is what creates the wave and gives it the energy to transfer. Mechanical waves can be divided into three main categories, according to the ways in which they travel, known as propagation. The three propagation types are: a transverse wave is one that vibrates at 90 degrees to the direction the wave is moving. For example, if you hold a slinky between two hands and shake it up and down, you'll get a wave that moves along the slinky, but the vibrations will still be up and down. Underwater waves are also transverse. A longitudinal wave is one in which the vibrations are parallel to the direction the wave is moving. That's like sending a pulse along the length of a slinky, pushing it lengthwise. Instead of peaks and troughs, longitudinal waves have compressions, areas where the slinky is bunched together, and rarefactions, areas where the slinky is spread apart. Another example of a longitudinal wave is a sound wave. Although you can't see air molecules, if you could, you would notice that sound involves air molecules hitting each other, thereby producing areas with high densities of molecules, compressions, and areas with low densities of molecules, rarefactions. Last of all, a surface wave is a wave that travels along the boundary between two materials. For example, the kind of water wave you most often see along the top of the water is an example of a surface wave. Surface waves move in similar ways to transverse waves, but are a bit more complicated in their behavior. In the case of an earthquake, you get a mixture of all three types of waves. The initial earthquake, called the primary wave, is longitudinal, but the aftershock that comes later, the secondary wave, is transverse. Extra surface waves are also created. Mechanical waves move through a medium, and because of that, the nature of that medium affects them. For a material to allow a mechanical wave to pass, it has to have some elasticity. Elasticity is how quickly the material returns to its original shape when stretched. The exact elasticity will affect how fast waves can travel through the material. Those with higher elasticity have a faster wave speed, because they spring back to their original shape faster, allowing the vibrations in the material to move more quickly. Other factors that affect the speed of mechanical waves include: tension is how much force is being used to stretch material. A stretched rubber band is under tension, for example. Temperature is a measure of how fast the molecules in a substance are moving. Density is how tightly packed the molecules in a substance are. Higher temperatures and tensions lead to faster wave speeds, since the particles are able to travel further before transferring their energy to the next particle. Higher densities lead to lower wave speed, because the particles don't travel as far before hitting another. A mechanical wave is a vibration in matter that transfers energy through a material. Mechanical waves have peaks and troughs, frequencies and wavelengths. Frequency is the number of waves per second, and wavelength is the distance from one peak to the next. A mechanical wave is created by putting energy into it. You could do that, for example, by making a sound, or throwing a stone into the water to create ripples. Mechanical waves are differentiated by the ways in which they travel, called propagation. The three types of mechanical waves are transverse, longitudinal, and surface. Surface waves run along the border between two materials. Transverse waves are waves in which the vibration is at 90 degrees to the direction of motion, and longitudinal waves occur when the vibration is parallel to the direction of motion. Mechanical waves are affected by the nature of the material or medium they move through. This includes elasticity, or how quickly the material returns to its original shape when stretched, tension, or how much force is being used to stretch a material, temperature, or a measure of how fast the molecules in a substance are moving, and density, or how tightly packed the molecules in a substance are. Materials with higher elasticity, temperatures, and tension have faster wave speeds. Materials with higher density have slower wave speeds.